want to talk about is, you don't need to write this anywhere. So with proportions, we have two things. We have an interval, we have a mean. When do we use interval and test? When do we use pooled? Why? Because we are making at the beginning of every test, we're making a claim. So we're making a claim about the proportion, which means we're claiming they're the same or not the same. So in this portion of the equation, if it were interval, this is p hat 1, 1 minus p hat 1. This is p hat 2, 1 minus p hat 2. If I'm making the claim that they're the same, does this change? Does this change if I'm making a claim that the proportions are the same? These all become p hat c, right? So this same drawing but with means, so what does it look like with, let's just do the ones with s's because we deal with the most. What does our equation look like for this portion for means? If I'm making the claim, I would have to make the claim that the what are the same. So wait, here, for my proportions to be the same, the p would have to be the same, right? For here, if these were the same, and I wrote it as, so like let's make up a number. Let's just say our standard deviation is 10 here. Right? If I now change those to be pooled and put them together, would that change anything? I would just write it as what? This exact same thing. So if these are already the same, does it matter if I write them as pooled or not pooled? So it actually doesn't matter about this, but we don't deal with pooled at all for means. But technically, if it so happened that the standard deviations were the same, why would it matter if I told the calculator that? Because it's going to do it the same anyway. Does that make sense? So like worst case scenario, they actually are the same. Okay, the calculator does it for us. I'm mentioning this because on your orange sheet, it actually has pooled on there. Pooled for means is a real thing. It is not something that we deal with. So we saw this yesterday. When we dealt with proportions, is there a scenario where we are supposed to use pooled with proportions? Did I have an option in the calculator? No. Because when I did a test, it pooled for me. Here, when I dealt with means yesterday, did I have an option to do pooled? Yes. So if it is an option, don't pick it. If you're supposed to do it for our class, it's going to do it for you. So don't deal with pooled at all for me. And most of you would have been fine if I had never told you that, but some of you might see something somewhere. It's actually in your book, and your book even says, hey, don't use this, but this is what it is. So this is for step number 10. And we're in chapter 10. So this is a 2-sample test for difference in means. And because we're not even dealing with pooled or anything, I really shouldn't need to tell you anything to write on this paper, and you can do the whole thing yourself. Go ahead and have one out from yesterday while we do this. So where do I start? Let me one. Be the mean context for population 1. Then I'm going to do the same thing with whatever my second mu is. So because we are doing a test as opposed to an interval, I go straight from defining my variables and population within to doing what?
It's supposed to be for population 2.
Oh. Thank you. So null hypothesis is going to be what? And now I get to pick the direction, but in general, and what symbol has to be there? Equals, and same scenario as last time. Some number goes there, but almost always we're going to use what? 0. Just like before, it makes a lot of sense in scenarios why we would want to do a specific number. If we want to make sure that you change the mean by a certain amount, like with a new online resource or something like that, you want to make sure it changes it by a certain amount. But for the sake of our class, most part we're going to be going with 0. And it is a test, so the last thing I also have to define is alpha. Alright, so plan. What's my first part? Method. And this is a 2 sample. I get a decision. Z or T. I'm not going to forget to write it today. What do I need to write when I write that? And I've talked about this yesterday too. Technically I can use either one, but which one am I almost always going to use? T. And then this is today we are dealing with test, and then for difference in means. We got to check our conditions. First one being random, and nothing changes since the very first day we started this, except we're doing it for 2 of them. And again, we're explicitly stating both of them out, not just writing the words for both. Normally we have 3 options. What's one of them? So stated, however I wrote this yesterday, both population 1 and population 2. Or write it the same way you wrote it yesterday. What's my second easy option? So N1 has to be greater than or equal to 30, and N2 greater than or equal to 30. The central limit theorem. Or my third option would be having to do what? And I don't remember how I wrote this for this class. At least in one of my classes, I wrote for each instead of for both, so that it doesn't look like you're combining them. But you might just want to stay consistent and write whatever you wrote yesterday. And the 2 things that you're checking for. No strong skew, no extreme outliers. And then regardless, I end with, so we can use normal approximation. Then my last condition, independent, 10% condition. And however you wrote this one. The same way we always have checked 10% condition. Brings us to do. What are we we going to be given in the problem?
X bar 2.
X bar 1, what else?
X bar 2.
So again, like I said, I choose to put those together, but also samples together. What else from sample 1?
N1.
Which means I'm also going to have N2, and then what else for both samples? S1 or S2, or S1 or sigma 1 and S2 or sigma 2, but most likely it's going to be S. And then because it is a test, I definitely also have what? Test today.
1 or 2.
So what's the same thing as confidence level but for test? Alpha, and then you said the other thing is what? 1 or 2 tails. And then technically we might have degrees of freedom, but we don't want to write that because we don't want to contradict ourselves. So our test statistic equation, I'm going to write the first one, the one we typically see. So what goes in the numerator?
X bar 1 minus X bar 2
And then technically it's what?
plus
But what is that number usually? And I didn't write that here. I don't care if you do or don't, but that is usually 0. So if this is 0, am I going to count off if you don't write minus 0? Mathematically, does that really change anything? No, but I always like to write it because you're kind of reminding yourself it's there. And then so if I'm doing the way we use the most often, what would this part be?
S1 squared over N1
And then plus,
S2 squared.
I might just do this and say, if you want to write the equation over, you can, but it's either going to look like this or the sigma instead.
Can you rewrite it with this?
You did it this way, everything on top looks the exact same. The majority of the bottom looks the same. It's just I have a sigma here instead of an S. And then so anytime I do a test, I get my test statistic. Once I have my test statistic, I put what on paper? The graph. You're going to draw it and shade it. And then from there, I get my what? It doesn't look. From this curve, I get what? A p-value, and I'm going to compare it to and just like the way I usually write it, less than or not less than. So conclude what are our two options? Fail to reject or reject. What is it that we reject or fail to reject? So we reject or fail to reject our null hypothesis. Why? Since the p-value is or is not less than alpha, which means that we do or do not have enough convincing evidence that, and our basic way is just to write whatever our alternative hypothesis is.